tonight. So tonight, I wanted to kind of scale back because we've been going hard with Kubernetes and GitLab and a lot of things that were um, new for people, and I wanted to do just a basic install with Linux using I have VirtualBox. Well, I have VirtualBox and VMware Fusion on my machine. And the little background is I'll just partition like 100 gigs on my machine. We're gonna just do a base install of it, and then we're gonna just talk about what a lot of things mean, and then so what you did an install, now what, like what do you do next, and I'll walk you through some things that you can do next, because instead of you doing what we're doing, you can automate the install, so that way you can always get your environment back. So we'll talk about some different ways to you can have your environment replicated in 15 minutes. That way you don't have to do this every single time. What does that look like and why? All right, so if you get downloaded this, I think this is a CentOS minimum disc that I downloaded for 7.6, and you see down here I'm downloading a DVD here, but that's the one that has everything on it. So that's gonna be a minute. And so let's make this a little bigger again. I may be a little slow on some stuff. Is that too big for everybody? Why we're not clicking through?
We can see it.
Huh?
I said we can see it.
Okay, it should be. I made it big. You should be able to see this one. So, okay, so I chose English as my first language. You can choose your own. You can see it automatically defaults to my laptop time zone. Is picking up that system time zone, and that VM is picking up that time zone. And installation media, because I picked minimum install, I don't get any options. In the DVD I'm going to get options, so this is going to be a real quick install. It's a real slim down version, and that's really all we need for now. Here, I'm wondering why it keeps choosing this 430 gigabytes, because I just partitioned this. And let me see here, can I add a disk? Nope. We're gonna have to go back and figure out why it's trying to choose my whole disk, because that's not what we want. All right, let's go out. Let's quit and let's escape out of this. Come on back, screen. You can do it. There we go. All right, let's close that out. It'll suspend for a second. That's fine. All right. So I'm on my Mac. So if we go over here to applications, and inside applications, you go to utilities. Inside utilities, you go to uh, disk utility. And I've already partitioned this out. I had added an extra 100 gigs in here. So let's see if we can show everything. There we go. There it's unused, but you know what? I don't know if it's been formatted. So let us do this. Let's see. We can partition. We don't want to do that. We want to do the Linux. So what I'm gonna have to do is destroy this Linux one. Let's erase that. All right. So we got that pretty much done. All right. Let's go back up here. Should be able to unmount that. Should be a gone. Yeah. All right. So let's do this. We got we got 100 of our gigs back. Yeah. All right. So let's add a new partition. We leave it as this. I'll call this Linux-2. And this is what I did the last time, and I don't know why it's not choosing that. I might have missed something when I did it. So I'll do 50 gigs for this one because I'm not gonna make big partitions. I'm gonna make little small ones. Let's add that. Okay, that's done. Okay, so now let me come over here. Partition. I don't know why it keeps showing me that. I don't want to increase, but let's try something. We have a volume here and there. And let's go back into our VirtualBox. And let me get out of the huge mode. All right. And let's go into hard disk. And let's choose my disk. Let's see. Did it give me any options? Bus type. I see this virtual VMDK, but I don't see my hard disk. Let me see something. New disk, existing disk. Not letting me do that. This is a conundrum. Where is my disk? Let's see. Because I partitioned it. I'm going to my settings. On a hard disk, the same thing. It's trying to pull this Red Hat stuff, but that's not it. And it doesn't let me adjust the size. Your hard disk cannot be changed until the virtual machine is shut down. Okay, cool. All right, let's shut you down then. All right. Oh, my bad. Get this. Are we not officially shut down? Resume. We're not officially shut down. Okay. Here, that's the pause. I don't want to quit. I just want to turn you off. What happened to the turn off in VMware Fusion? Anybody? Nobody else? Oh, I'm not even looking at the comments. Okay. Let's go look up turning off VMware Fusion. Oh, I'm gonna go to me. So let me click in. General. Okay, see? There we go. 54. No, that's 54 megs. Where is my hard disk? Let's find out. Turning off VM. I don't want to quit it. I just want to get you to power off. Nope. So, startup disk. Hard disk. Nah, that's not. I want to keep that the same. That's for when we start up our VM. Let's see my camera settings. That's that. That's my current state. If we want to take a snapshot, we don't need a snapshot. Can I do that? Yeah. Let's do a new one. From let's continue. Let's do that. I want to do something else. I want to do that, that's fine. But I want to choose my partition. That's fine. Test two. We can add a drive. Here we're gonna add um, a CD. That's fine. Show all. Um, that's cool. We're gonna go here. That's connected. We need to choose the disk. And the disk is in my downloads. It's a minimum. And then let's go there. Let's see if we get the same thing. Click into the box, install. Let me click out of here so I can move this down. Move this guy out of the way. Don't make it so big. Here we go. Let's see if we get 20 gigs this time instead of 430 gigs. So as this goes through, it's going to detect my CD. It should detect the size of the drive. Let's hit continue. Click in, and slow response there. Okay, dump. Yeah, I gotta wait for it. There we go. All right, so there we go. We got the software minimum. Let's go over here to partitioning. There we go. That looks a whole lot better. All right, so with this partition, I want to show you this. I'm gonna say this is what people do, like when we're first making it, but then I'll show you what happens after we make this. So you can automatically configure your partitioning, or you can say, I will continue, I will configure my partition. And then you say done, and it gives you the next screen, which in here it asks you, do you want to automatically configure this or you want to do this? I cheat, and my cheat is to do this, is to have it automatically configure, but remember I only got 17, I only got 20 gigs, so I get a boot and say I want to put var on something, so I can give this 10 gigs here, and then that gives me that 10 gigs, and then I can click another one and do slash var here, and I took 7 gigs away, so I can put 7 gigs GB on here, or GIB, and you do the mount point. So now we got 10 gigs for root, approximately 7 gigs for var, and then slash boot. Now, why did I do that? Okay, so one of the reasons is partitioning for NIST standards. So when you start hardening your machine, you have to partition your drives, your hard drives for NIST standards. I should say Linux partitions, so we can get that information. So out here, we have to have. Well, that's 2017. That might be all right, but let's look at this. This may fit what I want. So yeah. So rule of thumb is when you're doing hardening, you need to follow NIST standards, right? And so NIST standards tell you you need to have a slash temp, a slash var, a slash var log, a slash var log audit, and a slash home. And if you are feeling fancy and free, you need to encrypt all your partitions. So really what we should be making is we should be creating a logical volume group for slash temp, for slash var, for slash var log, for slash var log audit, and for slash home. And when I talk about volume groups, I'm talking about here. This is a volume group that's created, and I'll show you what that looks like once we get up. So what's the difference between a volume group and just creating a partition? Well, if you created a partition, you can grow the partition, but not dynamically. Meaning, with slash boot, if I run out of this 1 gig space, because it's not in a volume group, and I don't think they recommend putting slash boot in a volume group, but I couldn't dynamically grow that partition, but I can grow the partition, meaning I can use what we call DD. So DD Linux. So this is a direct copy for it. So DD command allows you to copy like an entire disk. So DD input file right here to out file. So I want to copy everything from slash dev SDA to slash dev SDB. So in this instance, suppose I created a partition for slash boot. I ran out of space. So then I can go onto my drive and create another partition, maybe label it slash boot to DD everything off of slash boot and then copy it over to slash boot to uh, remount unmount it, then remount slash boot to as my partition, and then go into the volume, and then go into FS tab, and then point everything to the new volume or rename the new volume. So that gets kind of convoluted and gets a little out of control. So versus logical volumes from Red Hat, I think the best guide is Fedora documentation. Red Hat documentation is good, but I like Fedora's. So they changed it some. Let me see where is an if this is the guide I'm looking for right here. Yeah, I like this better. So understanding LVM is came out in not Rel 3, but you when file system was using EXT3. So I want to say it came out in 5, 6. I know it was in 6. I'm trying to think if it came out in 5. I think so. But anyway, with logical volumes, what I'm able to do now, and instead of DDing everything off, I can just grow the partition. I can say, okay, well, I got 100 gigs right now, and I want to expand to 200 gigs. I can add a volume to that my volume group and then expand it automatically. And then the other thing that you had to do if you're gonna DD that stuff off, you have to have downtime. With the logical volumes, you don't have to have downtime, so you can do everything while everything is online. So that's what's really cool about logical volumes. So let me give you this link. All right, so let's go back to our partition. As you can see, we got a slash here. You notice no logical volume over here. My var, CentOS var, that's my volume group. Um, and root is in CentOS swap is in a volume group. So everything we have is set up in a volume group. So let's consider this done. It's going to ask you, do you accept these changes? You say yes. It's going to do its partition thing. The other one is, what do you want your host name to be? So you can come here and you can say Meetup. What's today? What's today's date? I don't know. I forget what's today.
27.
Oh yeah, 27. Okay, we'll call this Meetup 27. The other thing in here is you can configure your internet here. I won't do that right now. It's easier to do it in here, but I won't. Maybe I'll let it do its thing. I need to get an IP address. It won't connect out. I have to do my magic in VMware to do that. All right, so I'm just giving it a host name, and then we're gonna hit done here and security. So, security profile. So this goes back to what we were just discussing with the partitions. So originally there were people, and there still are, that what they had to do was build their Linux boxes, and then they had to configure them to be what we call STIG'd, STIG, what you see right here, and that's from a dis-a-STIG standpoint. So what would happen is we would build these machines, and then we would have to harden those machines. And those partitions that you saw are the partitions that you have to create in order to pass the security baseline standard for having your machine hardened. And on top of that, on top of that, audits, and on top of that, security hardening. So in here, what it's saying here, hey, we have a disastig for Red Hat 7. In here, let's see, can we scroll down? Let me see. Yeah. In here, I can follow for a Linux server, a desktop, a workstation. So let's go here and select a profile if it'll let me whenever it comes up. I'm sorry. All right. So here it is right here. You can see I selected a profile, right? But in here it says var log audit must be a separate partition, and temp must be a separate partition, and I don't have that, so I wouldn't meet the this is STIG standards if I wanted to have my machine set up for that. So let's click this off or change content. Here I will talk about the SCAP security guide. So let me pull that up too while we are talking. Did it pull it up? No. Let's see. Uh, OSCAP security guide. Are people still using this to this day? Absolutely. Um, and here's where we talk. We remember I've been talking about compliance as code. I've seen you all this because this is something that you want to discuss, especially when you're talking about doing things for your when you're talking about doing stuff that's considered around security. Here's how to follow compliances code for row 7, row 8. They got Ubuntu in here, the whole nine. And basically, here's the Ansible playbook to harden your machines in the whole nine. And they have all this already set up for you. So this is really, really helpful because the people that just this all they do, they just stig machines and keep them up to date. But now you got an automated process of that. All right. So I turned it off, and then we can at a later time we'll hold on to this, and we'll come back, and we'll make another VM that's probably the maximum size. Probably need about 75 gigs really, so you can make all your partitions so you got some space behind them. But we'll turn it off, and then we'll hit done, and then we'll begin our installation. And remember, I didn't do like this is just a minimum install, so I'm not going to get a GUI. But here we need to set our root password. And if we had this set up for state compliance, you would probably have to meet the minimum password rule, which would probably be 12 characters, one uppercase, one lowercase, special character, no two consecutive letters of the same back to back, So you couldn't have two capital N's back to back. It would have to be an N and a L, and one of them have to be uppercase, one of them has to be lowercase, and numbers as well too. So that's what you would do there. But for tonight's all intents and purpose, I'm gonna be cheap and I'm gonna do a very simple password, and let's see if it takes it. Look, the password you have part is weak. The password fails the dictionary check. It is based on the dictionary. You will have to press done twice to confirm. Sure and sure. I'll take that and we'll have it up and running. You can create a user if you don't want to log in with your root user. You can create a user here and then set yourself up and then log in and then sudo every time you want to do something, which is good practice. We should do so. Let's do that. Let's do this and let's give myself a password, require a password, or make this user admin as well. So let's skip that and let's come up with a password. And I'll make this password hard, which I should have made the other one hard, but hey, we're just doing a test run. And you can come down here for advanced stuff. And I can set up my home directory instead of being my username. I can do something else. I'm putting myself in a wheel group. I can change my ID here, but we'll talk about that when we get on the box. And let's just save changes. And let's call this done. And so we're waiting for this install. So far, are there any questions? And I wanted to make this kind of a simple class because I want to go over things like system hardening, things that we're still using in the industry. I want to talk about disastigs. I want to talk about, like, you see what I'm doing. I'm walking through this process of installing in a manual process, and then just think about it from this perspective. I'm doing this on here, right? And think about, I got to do this, say, 30 times. How would you set yourself up so you can automate this to do it 30 times, right? And say I had to build out 500 workstations. How would I build out 500 workstations? Like, how would I do that? And so these are the things that you have to look at and think about as you continue on your Linux journey, and then as you continue to start talking about automation. Yep, Ansible, Puppet, Chef, Salt, uh, you name it, you can use it. I prefer Ansible because I think it's easier to learn. I think the ramp up time to learn this is very simple. But when we get done with this baseline install and we come back, say in another week, we're then gonna say, okay, look, I want to build out 10 of these VMs, and we can chunk those VMs up into you know you know 5 gig size VMs, but you can automate the install of five of those VMs, and then have them sitting on your box. Just just to practice automation. So let's reboot here. It should automatically skip my disk here, right? And you can see here what the notice here. We got a rescue. We used to have our own rescue, but now they put that in as a baseline of it. I should just get a terminal prompt, and if you hit escape here, you can see the background of what's going on. If I hit escape again, it's gonna give me that line. If I hit escape, it's right now it's trying to come up, so that's gone. All right. So we just did our first Linux install. I'm gonna log in as root, bad practice, and now I am on my machine. That is a minimum install of Linux uh, on a 20 gig partition. Now, here's the fun stuff that you should know about when it comes to it. So we made those partitions, and I talked about LVM, and then I also talked about just a standard partition using DD, right? So how do we know what got created, and how do we know what is mounted on our file system? So if we type the command df-h, that gives us what's mounted on our file system. You can see that file system. It gives you the size. It gives you how much of that partition is used, the total size, and the percentage of what is used, and then where is it mounted at, right? So you see slash dev mapper CentOS root. Well, that's the actual root partition that's mounted on root. If I tried to unmount that, I couldn't, unless I was in rescue mode and I could, but whatever. And then that slash dev boot that we saw, that's mounted on a our main partition is SDA. Our main hard drive, I should say, is hard disk or hard drive is SDA. We didn't have another partition that we added just yet. If we did, it would go in sequential order, or you can rename it something else, but it'll be SDB. But here we got an SDA, and it has a partition of SDA has a partition one, so that's where you see the SDA one. So that's the first partition, and that's where slash boot lives. And then slash var, we see dev mapper, CentOS dash var, member volume group, and then a temporary file system. And we'll talk about tempfs. But if I want to know more, there's things about LVM that you should understand. And let's start with PVS, meaning physical virtual file system, PVS. And if I hit enter, it's going to tell me that I have physical virtual, what does it say? PVS, physical virtual uh, partition is SDA2. The volume group, the PV, the volume group is slash dev SDA2. The volume group is CentOS, and it's a format of LVM2. And it gives me the size, the physical size, and then the amount of the amount that is free on that on that volume group. So if we go back up here and look up our volume group, I mean our volume group CentOS, we see we had this. Let's look at it. We got slash dev mapper CentOS 6.6, and then slash CentOS, which is 10 gigs. So, and it's probably a little bit more. So this is approximate. So that's about right, right? 6.6 and 10, give or take some, you know, 5% to create. That equals out to that 18. So that's the physical volume group, right? But if I do VGS, that's going to give me my volume group. And that's where you see here, where we see that CentOS here, and I can't point here, but you're going to have to look at the first line, which is dev SDA2 CentOS. Now I'm reading what's in that volume group, and it's giving me that volume group. And if I do LVS, it's going to give me the logical partitions, meaning the physical partitions that happen with that. So our physical partitions, we know for a fact that slash dev mapper CentOS root is part of that, and it tells you the logical volume is root, the volume group it belongs to is CentOS. It gives you attributes of that, and then the logical size, and then there's more data that we can get for logical volumes. I won't get in that tonight because it probably confuse you, but it's really cool. We have swap that's in a logical volume, and it gives you the volume group and then the size, and then var, and then CentOS again volume group and then the size of it. So the next thing I showed you PV, physical volume, volume group, and then logical volume. But there's also a thing we saw earlier. We did LVM2, right? So we can actually log in to LVM2. Oh, it's not in there. So let me see if it's LVM. Yeah. So here's just LVM. Let's type help. And in LVM, it shows you I can do a VG scan, a VGS, again, display information about the volume group. I can remove partitions from the volume group. I can move partitions from the physical volume group up here with PV move, PV move and PV remove. I can display, I can scan my physical volumes. So suppose I added a hard disk and I want my machine to scan for that new physical volume because I want to add that physical volume to a volume group. So the logical order is, hey, give me some space, which is your physical volume, and then it says, hey, what volume group do you want me to add this to? And then, hey, you need to partition me out. So it goes physical volume, volume group, and then logical volume. Any questions so far? Because I want to make sure I don't lose you on this stuff. And if you did a default install for Linux, this will automatically create these volume groups for you. Okay, so we talked about the physical space. We looked at df minus h. We talked about the physical volumes. What I have not talked about is uh, how do we get that if we're in our inside our terminal, right? So if I did a f disk minus l, it's going to give me more information about my physical disk. So that information is slash dev SDA, as you can see, is 21 gigs. Remember, I chose 20 gigs, so like I say, it's a 5% difference there. And then it tells me more about my volume groups, and I mean my volume group, and then the logical volumes under those, the 10 gigs, the swap, and the var. So that gives you that. And now if I wanted to know more information about this, let me do a f disk, and I know the partition, I know the actual physical partition I have, the physical device I have is SDA. So now I'm inside of the partition on my machine of SDA, and I can do a P, or let's just type M so you can see the menu. So M, I can edit some labels up here with B, with W if I want to write to the partition, but right now I just want to print partition information. So I'm just going to type P. So when I type P, it tells me about my physical device slash dev SDA. It tells me I have a partition on as slash dev SDA1. It also tells me I have another partition at SDA2 that's of LVM. And the IDs are over here. So 83 and AE are the different IDs that are associated with the actual partition label that you choose. So 83 is just a regular Linux, and then AE is LVM. And you can change that. So if I type T, so yeah, see, now it's trying to tell me about the default. What do I want to change? So I'm going to control C out of that. So let's go back in there because I want to see if I could get the partition, um, if I can get the label list. Oh yeah, so it's L. So in here, you got different labels that you can label the partitions. Most of the time, we're gonna probably stick with 83 and AE, unless we're doing something else. Like if we need a VMware partition, we could do that. If you're doing OpenBSD, I don't know nobody that's using Novell and NetWare. FAT32. If you want to, I guess, play around with an older version of Windows, but most of the time it'll probably be NTFS over here on at number 7. The other ones, I don't know anyone that's using old Minix. I don't know anyone using Amoeba. OpenBSD, yeah. NetBSD, maybe. Solaris, I don't even think you will be on a VMware box if you're using Solaris. But this is how you get to see what other partitions you can label and so forth. So that's quick. I just wanted to give you a good quick rundown on that. All right, let's clear. So number one thing about being in Linux is how do I get to where I need to get to, and how do I move around, and why do I want to move around, and what does each directory mean? So I'm gonna do a ls, um, a long listing of slash, right? And you can see I did a ls on slash, and you'll see different things in different colors. And you'll also see some things that look like may look strange to you in terms of being green. So one thing you can always do if you don't remember something, what command you type or whatever, there's a couple of things you can do. You can use the up arrow, or I can back out of this, sorry, and use history, and it's going to give me all the commands that I've ran. So, but I just really want to use my up arrow for this one, and I want to go back over here and I want to do a minus L. So the minus L gave me a little bit more information than what I had before. And that information is about my permissions on my directory and folders. And then it also gave me permissions on who owns it. And it also gave me timestamps. And it also gave me what you don't know is SE Linux is on, but I'm going to show you that in a minute. So let's clear because I want to show you another command. So ls minus L, and if I do capital F, now I'm getting to see like what I'm actually dealing with. Everything on here that has a slash behind it, those things that have a slash behind it are what we call directories. But you notice that you have the lime green bin, lib64, and sbin. Well, those are what we call symbolic links, and they should be soft links versus hard links. And I won't get into hard links versus soft links tonight, but over time I'll talk about it. Just make sure you remind me. Put that on a chart or something somewhere, or post it in Slack. And then we have temp down here in green. Well, temp has its own thing, but let's go down this one by one. Bin, the bin directory or slash bin directory is usually where you'll find, you see it's pointed to user bin. Usually that's binaries that you can find for the system. So if I did a ls on bin, it's going to point me to, because there's a symbolic link from bin to user bin. Like it's just like I guess you can consider that like a URL shortener or something like that. Like I got this long thing I wanna go to, but I don't want to type the whole thing to go to. So I make a link to from for this long thing using this short thing. So now I just type the little short name, but I actually go to this long name. So if I do a ls and bin, you see a whole bunch of binaries in here. That's what they are. Binaries and symbolic links. So basically, most of the time, when you're writing command, like let me see, let's do time, and then let's do which time. So no time there's not in user bin. It's in one of these binaries that comes up. But let's do which who. Okay, bin who. All right. So under slash bin, if I don't know where I'm at right now. I'm in root, so I want to change directory cd over to bin, and I'm gonna clear my screen here. I'm gonna do an ls. If I look for who, which is on my right hand side, you'll see that it's green and it's a binary. So basically, I should be able to run dollar slash who, yeah, and it gives me more information about myself. It's a binary, so and I have permissions on it to run it. So let's back up a little bit. Let's go back up to slash. Let's clear my screen, and let's do an ls minus L. All right. So when I talk about permissions, that first column should be your in your eyesight, and the column, I should say, the third and fourth column should be in your eyesight. Those two things are very important. So the first column gives you what permissions are available on that particular folder or directory or link, and who owns it, and that's the third and fourth column. So the first column, and I'm going to give it to you. I don't know how many people have played along with Linux and understand these things, but I'm going to break it down for you so you can understand it. So in the first column, you see a L, and you look at that bin and the color of it, and I think on most of them when they do switch colors now, you see that it's that kind of like a, I don't know, a green lime green. I don't know what you call that, teal or something like that. But anyway, you see the L on it, and that usually means it's a link or some symbolic link. So, and you can see it's pointed, saying that hey, this link actually points to user bin. So that's what that means. But what's very important about it is to not just the fact that there's it's a link. I just want to say, when I say that, that's what I'm typing. That's what I mean. That by the L represents that link. So L equals to link. But what's important is this RWX. And I'm going to chop this up into pieces like this RWX. And I'm still looking at bin, the very first one, and then RWX. All right. I chopped it up into threes because those threes equal to this. They equal to user group, and I should type this out, user group other, right? That's what those mean. User group other. Those three, the RWX, RWX, RWX. And you can see it's different as you go down the line, right? So what that means is the user for user bin, or the link that's pointing to user bin, the user, the group, and the other all have RWX, which means they all have what we call read write permission, and it goes like this. Read write goes 4 2 1, and I'll do this 4 2 1. I'm dividing them up, and then 4 2 1. All right. All that means is the way we calculate our permissions on a file or a directory or a link. They all are in what we call, I believe it's called, is it octo? I think they're in octo. Octal is what I'm saying. So what we get here is 4 2 1. We add that up. So that's, I may be thinking about the directory. But anyway, 4 2 1 is 4 plus 2 plus 1. So that's equal to 7. And then again, that was for the user. The next one is 4 4 plus 2 plus 1 for the group. That's another 7. And then 4 plus 2 plus 1 for the other, meaning you're not the user, you're not in the group, you're something else. That's 7. So the permissions on this is 777. The true permissions on this is actually 077. That's where I was going with the octo stuff. So that's what that looks like. So let's walk down to the second one, which is boot. All right. And let's go over that. And then make sure you're paying attention because I'm going to ask you some questions. So the D that's out in front stands for directory. And the permissions on this is, let's type that out. It goes R, you got a dash X, not a big X, little X. And then we have R dash X. And then we have another one with R dash X. All right. Now, what does that equal to? All right. So remember, read, write, execute. When you see the dash in the middle, that means that permission is off. Now, I want you to remember what those permissions are, right? So again, it was 4, 2, 1 is what we equal out to. But what this tells me is on this particular directory as a user group and other, I have these permissions. I have, as a user, I have read and execute, which is 4 and 1. Remember 4, 2, 1. So 4 plus 1 is what? 5, right? Let me do a little space there. All right. The next one is I have same thing again. Group on the group. I have 4. I have 4 for read. The second dash is shown is off, and then I have X, so that's 5 on that, and the next one is 5, right? So what it tells me, my permissions is 555, which is actually 0555, and that's on slash boot. Those are the permissions I have. Meaning in slash boot, I don't have permissions on here to write to slash boot. I have permissions to execute on slash boot. And he said, in terms of who owns it, we have not talked about that. But before we talk about that, I want people to tell me what does the dev directory uh, represent in terms of, I just gave it away. Jesus Christ. Gave it away to y'all. But anyway, you get it. So we're going to say dev is a directory. But what permissions are on dev? We have read, write, execute, and then we break it up into threes. Read dash X, breaking it up again, and read dash X. So I want somebody to tell me what permissions it is, and I'm just gonna randomly call on you, and I expect other people in the group to help you out. Remember, this is a learning session, and I want you to learn these things. Again, this is gonna help you with your sticks, and when it comes to hardening your machines and security, this is part of that flow. So I'm just gonna call on you, and you can type it or you can write it. All right, so let's go. Let's go with Kiera. Um, what permissions do you see on the? We're looking at the dev directory, and what permissions is given to the dev directory. So first off, we know it's a directory, and you have to think about what you can do with a directory. So you have an idea of the permissions, and you can type it as well too. And T, you're up next, so I hope you're thinking about it. Okay, you got read write on what? Because you're missing one. So it's read write and execute, and then what else? What's the next? The next set. And what does the read write execute stand for? Sorry. So go ahead. I think somebody was talking. All right. So the read write execute again is on the first octet or the first set, and that's your user group and other. And that user has read, write, execute, meaning they have all of the permissions they need to do whatever. The next one, you see the middle one is off. So we got read and execute. And so that, remember, it's 4, 2, 1. So that person has 4 and 1, which is 5. And then read and execute on the next one is 5. And it's really, like I said, 0755 is the permissions on that particular one. And I'm going to add this in now. Look at who owns it. That we're looking at dev. So the user that owns this and the group that owns this is root. So that's the user and the group that owns this particular one. So I made a user called Tamika. So let's go over to slash home and sorry, slash home clear. All right, I'm gonna do a long listing with the LL. If you look at this, what permissions does root have on my particular home directory? Remember, it's you break it up into threes, RWX, and then the rest are 1, 2, 3, and 1, 2, 3, and that equals to user group and other. So what permissions does root have on my home directory if you're looking at it? Reggie, I'll call on you for this one. Nothing? Nobody? Is this thing on? I
Okay,
oh
so I'm not quite understanding. Could you explain that again?
Yep. All right. So I'm asking what permissions does the root user have
Mm-hmm.
on this particular directory? Right now, we know it's a directory, right? Can you see that?
Yeah.
Okay. So you see the D that's out in front, and you see that the way the permissions are set up, they go user, group, and other. So each this RWX that belongs to the user. That dash dash dash, that's the first set of dashes that belongs to the group. The next set of
Okay.
dashes belongs to other. So
Okay.
so right now on this directory called Tamika, I am the owner, I am the user, and I'm in the and I'm the group. But basically what I'm saying is if the root user doesn't fall inside the group and doesn't fall in other, then they don't have any permissions to my home directory. So nobody else has permissions to my home directory. Now you could be a super user and then fall into the wheel group and that all that stuff. Of course, you get permissions. As long as you got permissions to the box, you got permissions for life. But the rule of thumb is no one should have user should have root access or any type of access to your home directory unless you allow them to, or unless the actual admins allow them to have access to your home directory. And then on top of that, they don't have to have access to your whole home directory. It could just be a folder in your home directory, depending on how you set up your group partitions. I mean group permissions. So let's go back over here to slash and let's do a LL, and you'll see in here there's different permissions on each home directory, each link, and so forth. And remember, they all go 421 user, or not user group other, but read, write, execute. Read is 4, write is 2, execute is 1. 4 plus 2 plus 1 is 7. So if I make a directory and I call it my test, by default it should be 755. We'll talk about octo later and why it makes that 755, but let's clear and let's show you that. So I made a directory called my test, and you can see my test has 7 4 4 2 1 7, read and execute 4 and 2, I mean 4 and 1, and then read and execute 4 and 1. So that made it 755. But I now want to give everybody permission to write into that directory. So I want to do what we call a chmod 777 on my test. Now when I do this, it should change colors as well too. We're going to clear that. We're going to do it LL. Because I opened up my permissions to the world, I gave it world readable permissions, which is absolutely what you should not do. Everybody can write to it. The user can write to it. The group can write to other people can write to it. Everybody can write to it. You get a car, you get a car, and you get a car, right? And that's not what you want. The whole reason why you have things segmented out, and the reason why we do these things is because we want to provide some type of protection, and then we also want to provide some type of access, but we don't want to give everybody the world. It's like giving everybody access to your bank account. So, any questions so far? Anybody lost? All right, cool. Now, let's get down to the nuts and bolts of things. And those nuts and bolts, and I'm going to remove rmrf my test. That's how you remove a directory. And recursively, and because it was directory, I had to do the -rm -rf -rf. I'm sorry, rm -rf. All right, nuts and bolts. All right, /bin. We talked about this earlier. /bin binaries, and remember /bin points to user bin, meaning I could, like I said before, I can come in here and I can just do /who, and I run my who command, right? Why was I able to do that? Well, you should tell me, right? That's clear. Why was I able to run stuff in /bin? You see how wide open that is, that link is? It actually points to user bin. But let's go to user bin. Let's go back up one, actually. Let me clear. All right, and let's do an LL on bin. Bin has what? Read, execute, read, execute, read, execute. So it's telling me, you're welcome. Read, execute is telling me that I can execute in things in that directory and I can read things in the directory, but if, and the owner is root, meaning Tamika can't write to it. So you know what? Let's prove it. I'm gonna ask you to Tamika as a user, and I'm gonna cd over to user bin. I'm gonna ls, and let's try to write to this directory. Let's see what happens. I might be able to write to it because that symbol link may allow me to. So let's just touch hello. Yeah, permission denied. You know why? Let's exit out and clear. And come back here, because in the bin directory, I don't have write permissions. As a user group other, I don't have write permissions. But remember, I'm root right now, so I got super users. So if I log in, I'll be able to. I mean, if I go to that directory, I'll be able to change some things. All right. So the bin directory is usually where you find binaries. The etc directory is where you'll find configuration files. So anytime you want to configure something about the system, rule of thumb is start looking in etc first. etc etc. If you have an application that gets installed and you're not sure where things are installed at, we'll show you how you can find that out real quick. And so let's do that. Let me see what's a good package to install. Where you can find that out. Well, let's just query some stuff. So what I'm gonna do is I'm just gonna query all the RPMs on the system. I'm gonna pipe this over to less because I don't want to run off my screen. So I just did a RPM-QA to query the entire file system, right? But I'm doing that for a reason. And that reason is I just want to pick, let's look at grep. I just want to pick a RPM and get some more information about it. So I can do RPM-QA, no, not QA, QILC -- files by package and then let's type grep. All right, a lot of information, but never fear. Let's redirect that information over to temp, and then grep.text. So basically, what I'm saying here is I'm a query my RPM database, and we'll talk about that. And I want to get some information on it on the package that's installed, and I want to know the files by that package that was installed, and let's name it text, right? So whenever I don't know something or I'm not sure about something, you can always do RPM dash dash help, and this gives you more information about it. Another way you can find out about information, I can do a man on RPM, and it gives me more information about how to find out what switches I can use. And sometimes these have examples. One that we played with earlier and that we were looking at was LVM. So if I do a man on LVM, as you can see, I get more information about LVM and what my options are and what do those each one of those things do. And lo and behold, if you scroll down to the bottom, guess what I get? I get examples of how to use it as well too. So they have some examples in here on how to use LVM. So let's go here. Let's do a man on VGS. They give you volume group. They give you some examples in here. Let me scroll down. Environment variables. Where's my examples? They're making me out to be a lie. Holy cheese, Batman. All right. That's clear. Let's do. No. I lied. Let's go back. It's in there. It's at the top. I passed it. Oh, I'm lying to myself. Holy cheese, Batman. How could you do this thing? All right. Well, I lied. They usually give you examples. Let's do a man on LVS. I usually get examples. Let's go down. Environment variables, storage variables. I usually get examples in here. Well, usually for the test, I was going to say, if you're using LVM and you have to do some things on the test, you can usually hop into the man pages and it gives you examples. But again, the point I was showing you was the man pages. So I queried my file, right? And let's look at, let's see, is Vim installed? Nope, not installed. But that's okay. We can use VI. And there's other editors you can use: VI, Pico, Nano. I am not a Pico or Nano fan, but for tonight, against my warm, tender kisses of a heart, against my fingertips, it's okay, fingertips. We don't mean this. Gonna type Nano. And I'm gonna nano this file. Oh, good, it's not installed. Let's see if Pico is installed on here. Nope. You're forced to use VI. Oh, I knew this was a solid operating system. All right, so grep.txt. You see how happy I got? Boom, boom, boom. So this is the output I just from the RPM query that I did, and I redirected the output to go into this file. As you can see, I get an idea of what that RPM one, what it installed, and what it gave me access to. Well, as you can see, the first one, it gives me egrep, it gives me fgrep, it gives me grep, it gives me a chance to grep for colors, and I can change what I grep for, like when I run my grep command, what I want the output of my colors to look like, and so forth. But if you keep scrolling down to the bottom, this Etsy profile color grep.csh, you can see that it puts some configuration information inside of etc, right? And that's really what etc is just how you configure your application or the system itself to run. You can change um, memory, you can change NIC cards, you can change whether SE Linux is turned on or turned off. Just a whole bunch of things that you can do with XE. Put it like this: if you lose the XE directory or if you lose the root partition or the boot partition, yeah, you kind of screwed. You might as well start over. You can recover, but man, it's not worth it. Sorry. All right, so let's go back up. Let's go back over to root. Let's do LL on slash. The next one is that boot directory. We can look in the boot directory, but I'm gonna say that for last and dev for last. Home is usually where you put your home directory for your users. It's usually like when you do a user add, that's the default. Or sometimes some applications may have a home directory. I know GitLab Runner, it needs a home directory. It logs because it actually doing a login to the box and actually running commands as if it was a user. So you see lib and lib64. Well, the reason why you see that is because we went from 32-bit libraries to 64-bit libraries, and those 32 lib libraries still live and are still in existence on certain things. They haven't really fully pulled everything out of 32-bit that they needed in 64-bit, so they both have setups. What is one caveat that you should always be aware of for those that use desktops in Linux? When you're installing Firefox or Chrome, you need to make sure that you're installing either when you need Flash or something like that. You need to make sure that you're picking the right type of browser because some browsers are 32-bit browsers and some browsers are 64-bit browsers. And that matters because if you have a 64-bit Flash player, it won't work on your 32-bit web browser. It probably gets installed in lib64. So you have to be aware of those things. So remember, there's 32-bit and there's 32-bit and there's 64-bit, and that's why you see those two. Media, it is sounds just what it is. Media. That's usually where you mount your hard drive, your ISOs, or something of that nature, some external source you mount there. When it comes to MNT, it goes back and forth with M&T. You can mount there too, but there are mounts already there for M&T. Now, Opt been around forever. Opt is where, hey, I download a third party RPM binary or something like that. I'm gonna throw it in Opt. Proc. Well, Proc is really one of your main systems. That really gives you a sense of view of what your operating system is doing right now. Proc is your running, tells you what is running on your file system as we speak. So that's what you get for Proc. Root. Well, guess what? I logged in as root. Guess what? There's root's home directory, and that's about it. This root homes directory. Run. I have to look up run. I forget the real run. Let's see the order /run, and we'll see on here. All right, so under here we got some running stuff. Looks like we got our logs. Let's look up run. Let's go run directory Linux. Let's go Red Hat. File system layout, which is pretty cool to give you all this information up front. So again, like I said, 64, lib 64, 60, blah, blah, blah. Let's prepare your file system for upgrade. They got var run. They got a link to var run. Let's see, they got run in here. Okay, var run is a symbolic link to run. So okay, so let's go over here to var run. That probably is a symbolic link, so we're already there. So there's no need to go there. They don't talk about this. I forget. I can look at it and tell you the significance of it. That's the wrong guy. Do 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 do. All right, var run. So in here, looks like we got running PIDs. We got a running PID. These are actual running services on this Linux box that looks like are sitting here in run or var run if you look at the link. So we have cronny D, we got an audit D, we got e tables, a lock on e tables, we got syslog and SSH, and then we went over user bin, but then there's sbin. Sbin is usually an admin user has to have privileges to run anything that falls under sbin. That's what that is. I forget what SRV is. Temp, well, a lot of things get dumped in temp. A lot of things get spun up and dumped in temp, but temp has a special permission on it. It's called a sticky bit. Um, that's on temp. I should do LL here on slash, and you can see a T here on the end of temp. There's a sticky bit on it. One thing about temp is anybody can write to temp, but what happens is after so many reboots, whatever is there gets lost, gets wiped over time. So it automatically cleans itself. User, you usually find things like, and let me clear my screen here. If I cd over to slash user, you'll usually find stuff like user share docs. You'll find information libraries. You'll find like other user share. You'll find the docs. You'll find uh, user bin binaries and so forth. And then the last but not least on this file system is var. Okay, and we know why it's important about var. Logs, var log messages, var log audit, var some files like especially Docker application runs under var. So sometimes you may want to create a separate partition for var itself because some things just kind of grow exponentially. So be careful with that. And then I'm gonna back up to boot and dev. All right, so I skipped those for a reason. It's clear. And let's see over the boot. All right. So what we have here is what I like to call the meat and the potatoes. So remember when we booted up and we saw a rescue? Well, here's that system image VM Linux rescue. That's our image that we have. What is important about this particular directory is the fact that without this, we don't know what I should look like and what I should give. What we don't know what my system would look like, and we don't know what is rolled up in that kernel in terms of what modules are turned on, what modules are available to us. And when I say modules, I mean kernel modules. And we should we should do a class on um, we should do a class on updating kernel modules and installing them and writing our own kernel modules and stuff like that. Get down to the nitty grit, but I think next week we should do some kernel stuff so you have an idea of it. And you see two directories over here that are really near and dear to your hearts, and they will be after tonight is Grub and Grub 2. So here in Grub, not to get mixed up with a the insect or food. And let's go here to Grub 2. Oops, up Grub 2. May not be in there. May not be in there. Okay, there you go. All right, you see something very special in there called a device map. You see some fonts, and then you see grub.cfg. All right, let's no vim on here. Let's vi grub.cfg. Well, here it tells you right here, do not edit this line, blah, 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 this file, so forth and so on, because this is what gets used on your boot. And you can see like load video. And remember, I talked about modules that get booted. Here we go. When I talked about what your terminal and console and stuff should look like. That splash screen we saw in the other one is that splash screen that you get when you first boot. We should talk about the boot process of Linux, but what is important in here is anytime I install a kernel in here, this file gets edited and it tells me what I should load in that kernel. It also tells in terms of module, and it also tells me what image I should use to load for this particular boot process that I'm going to. So you can have multiple kernels on a Linux box, and you can pick which one you want to be in. So you may have one kernel. You may have one particular kernel that has like all your video drivers in it, and then you may do a yum update, and then it replicates. It should keep that kernel if you have on what we call DKPS. But if it doesn't, if you don't have that turned on, all your modules that's installed in that other kernel won't be in this new kernel. So you may get a blank screen, or it may not function the way it should before. So now you have to kind of reinvent the wheel all over again. But there is a way around that. So that is the big one. And then the other one is slash dev. And dev sounds just like it does. Devices. So in here you'll find all of the hardware devices that are from the operating system to the physical hardware. So if I needed to say I needed to do, especially if you're using like a server or something like that, I need to use a pass through from my VMware server to the actual physical device. I can actually access my physical device in terms of memory, or a hard drive, or some type of back end that I need to hold. I mean, I need to have access to my actual VM. So in here, I could probably manipulate this because I got a hypervisor here with VMware Fusion. I have a hypervisor here, so I could probably uh, get some physical access to some things, and it's natural. Like up here with let me see, properties. Oops, not snapshot. Settings. So in here, I got my network adapter shared with my Mac. You see that, right? I also have some sound. My display. I also have my camera. Like I can allow my camera again, physical access back to my hardware here, and that's through here. So if I can access it through the settings here, 9 times out of 10, once I get that access through my settings, naturally I can get the access to the actual, VM that I'm using right now. So there are certain things that I can get access to from my laptop directly to my VM. And again, this all comes down to your slash dev and your libraries that you have set up on your system as well too. The other key caveat in here, you should see things like the TTY, the terminals, and that is when you're able to go in between virtual terminals on a Linux box. So on a Linux box, I can have with the keyboard, I can access 7 virtual terminals on here, but then I also have virtual terminals when I log in as well too. And in here, you also find slash dev SDA. That's your directory, your physical device, and then slash SDA1 and SDA2 are the partition devices that we saw earlier. They all live under here. So guess what? If you delete it, guess what should happen to your machine? Should be dead. So don't delete it. So don't do a rem dash rf on slash because you're gonna delete everything, and don't do it on boot. Just don't do it. If you want to test that theory out in production, just make sure I'm not there. But yes, these are the meanings behind all of the uh, Linux directories, why they're there, what are they used for, how do you get around them, what are the permissions, what are symbolic links. We didn't talk about hard links because I don't know anybody that really used hard links. We talked about partitions. We talked about LVM. We did an install as well too. And this was all just a minimum. And I showed you how to open a file using VI. I showed you how to do an RPM query. I didn't show you Yum. Let me see. Do I have an IP? Yeah, I don't even have an IP, so I didn't even fool with that. I should give myself an IP, and then next week we can go over again. How do I clone this install, right? Because I need 5 of these machines stood up or 10 of these machines stood up, and I don't want to walk through just the bare the clickety click. So if I go here to slash root, this is something I wanted to show you. So in slash root, after you do an install, you get anaconda config. Basically, this anaconda config is a working installation file of what you install, what you handpicked, and what you install. So basically, what can happen is I can take this particular file that I have and I want to replicate this install again. I can put this out on a web server somewhere, and then I can point to that web. I can point during my install to that web server with this file out there, and I can start automating the install of this box so I can get the same thing back again because it's given to me. And so now I can say, okay, well, let me automate the install of this box again. So I can go back and do an automation install of this box. And next week we should set up a Kickstart machine. We should set up and I should make a repo for that, a Yum repo for that, and then set up a Kickstart machine and the whole nine. And that way you can access it and you can start building out 5 little VMs that you want to have on your box. Again, they don't have to be big VMs, just 5 gigs. And they don't need to have a ton of memory. You probably can get away with 3 for some of the things that I want to do. We'll build back up to building our own Kubernetes cluster inside um, in our side of environment, but we need to automate everything in order to get there. And so that's going to include how do we use Ansible? How do we use Terraform? How do we use all the tools and stuff that we talked about to build out this cluster? And then once we get the cluster built, we're going to deploy to it. So it's going to be an ongoing thing. And I want you to be able to use GitLab to check in your code and stuff like that and share with each other. Why am I showing you this? This is from an infrastructure side. This is not about me showing you microservices and making applications. We haven't gotten there yet, but I just want to show you the functionality behind a lot of the things that you use. If out in the real world, Linux is underneath. And trust and believe, somebody out there has an automated script to partition some machine out there in the cloud so that you can use it. Trust me, they do. So any questions?